Hi again, my dear students. Now we are going to make our mathematics semester 1 exam review worksheet. We are going to solve now problems for our topics covered in semester 1. Please be ready, concentrate, and follow the rules that we discussed before because they will help you too much. Are you ready? Let's start. Question number 1. In question number 1, we should complete with the correct number, using the correct number. In the first one, we have multiplication of signed numbers. If we look at the answer, we find the sign is positive. So we ask ourselves, here we have a negative. Negative times what will give us positive? We know that negative times negative will be positive. Now 9 times which number gives us 45? 9 times 5 will give us 45. So it's very important to know the sign of the result before multiplying. Also the sign of the result is negative. The given number sign is positive. So what multiplied by positive gives us negative? A negative multiplied by a positive will give us a negative. What is multiplied by 13 and it will give us 13? Minus 1 times 13 will give us minus 13. Now the sign of the result is negative. So positive times what gives us negative? Positive times negative will give us negative. 7 times 10, it will be minus 70. Now the sign of the result is positive. So positive times what gives us positive? Positive times positive. 3 times 9 will be 27. Now 55 times what gives us 0? Always when the result is 0, so any number multiplied by 0 will be 0. Now we start with division of signed numbers. We have a negative number over what gives us positive? Negative over negative will be positive. 20 over what will be 2? 20 over 10, the answer will be 2. Now, which number divided by 6 gives us minus 6? Because the result is negative, so negative over positive is negative. And which number divided by 6 will be 6? It will be 36 divided by, minus 36 divided by 6 is equal to minus 6. Now 5 to the power 4 times what gives us 5 to the power 7? This is one of the rules of powers that we discussed before. Here the base is 5 and the result's base is 5. So two same bases power will give us the same base. So the base is 5 and we know that it will be multiplied by a number of base 5. Now we should add the powers. 4 plus what gives us 7? 4 plus 3 will be 7. So 5 to the cube 5 to the power 4 times 5 cube equals 5 to the power 7. Now here we have same bases, so to know the power we should add these exponents. Which number added to 2 will give us 10? 9 to the power 8 times 9 to the power 2 equals 9 to the power 10. Also here we should have bases of the same power, powers of the same base. So here the base is a 3. 3 to the power 0 times 3 to the power 5 equals 3 to the power 5, because if we added 0 plus 5 it will give us 5. Now here is the second rule of powers. If you can remember, a to the power that we talked about, a to the power m, all of it to the power n, we multiply the powers or exponents, so it will be a to the power m times n. So 6, here the base is 6 and the base is 6. 7 times what gives us 42? 7 times 6. Now this is a rule also. We have 3 times 10 to the power 4. So as we know, the power is for 3 and the power is for 10. So it will be 3 to the power 4 times 10 to the power 4. Also here, because we have a number multiplied by 7, all of it to the power 6. So here the missing number is 2. So 2 times 7, all of it to the power 6 equal 2 to the power 6 times 7 to the power 6. Now if we have a fraction 7 over 11 and a missing power is equal to a number over 11 to the power 7, so here because we have 11 to the power 7, so the exponent should be 7, and here the missing number is 7 to the power 7. Now 1.3 to the power what? All of it to the power 11 equals 1. Here we multiplied these powers, so what times 11 will give us as a power 0? Here if we multiply 0 times 11 it will be 0, so 1.3 to the power 0 it will be 1, because any number to the power 0 it will be equal to 1. Now a to the power what? All of it to the power 4 equal a to the power 20. Here we should multiply the exponents, so a to the power 5. 5 times 4 is 20. Now here we have a power of base 10 because the base of 10, so the exponent will show us how many zeros we have near 1. 1, 2, 3, 4, 5, 6, so 10 to the power 6. Now 10 to the power what equals 1? Because we have 1, so here we have no zeros, so the power or the exponent should be 0. Now 10 squared, all of it cubed, times 10 to the power 1 equals to what? Here to the first one we should apply the first rule of power, so it will give us 10 to the power 6 times 10 to the power 1. Now these two powers, because they are of the same basis, we add their powers, it will be 10 to the power 7. Now this is a power of 10, so we take from the base, we take the 1 and we add near the 1, 1, 2, 3, 4, 5, 6, 7 zeros. Now in question number 2, we consider the following system of axes or an orthonormal system, x prime x and y prime y. The x prime x is the horizontal line and the y prime y is the vertical line. In part A, we should locate the points. E has an abscissa minus 3, so on the x-axis E is minus 2, it has an abscissa minus 2, and it has an ordinate 3 to the positive side. Now we draw an orthogonal projection from 2 and an orthogonal projection from 3 where they intersect, they give us the point E. F has 3 minus 5, abscissa 3 where it belongs to x-axis, and ordinate minus 5 where it belongs to y-axis. Also we draw orthogonal projections as we said, and where they intersect, they give us the location of F. G has 7, 0, so it has an abscissa 7. As we said before, when any point has an ordinate 0, it will belong to x-axis, so G will be on x-axis. Part B, find the coordinates of point M. This is M. We should draw an orthogonal projection from M down to the x-axis, an orthogonal projection from M to y-axis. Now we can see that it has an abscissa 4 and an ordinate 3. So M has 4, 3. P, now let's look at P. We can see that P belongs to x-axis. So it has an abscissa minus 4. Any point belonging to x-axis has ordinate 0. R, now it belongs to y-axis. So it has an abscissa 0 and an ordinate minus 3. S, we draw an orthogonal projection from S down to the x-axis and from S to the y-axis. So S has an abscissa minus 5 and an ordinate of minus 2. Now in part C, we should join the points E and M. Let's join the 2 points E and M. What do you notice about the line EM and x prime x? The line EM is parallel to x prime x. Why? Because E and M, the 2 points E and M, have the same ordinate. Any point, 2 points having the same ordinate will form a straight line parallel to x prime x. Let J be the orthogonal projection of f on y prime y. This is f. Let's make again the orthogonal projection from f to y prime y. The orthogonal projection is the perpendicular from the point to y prime y. Now this is J. Find the coordinates of J. J, because it belongs to y prime y, it has an abscissa 0 and an ordinate of -5. Now let's find PO, the algebraic measure PO. This is O, the origin of the axis. Because we are going from the negative side towards the positive side, we are going towards the positive, so the sign of the algebraic measure PO will be positive, and we count 1, 2, 3, 4, so it is +4. Now OR, this is R. We are going from O towards R, so we are going towards the negative, so the sign will be negative, and we count -1, -2, this is 3. Now in part F, let I be the midpoint of segment EM. Find the coordinates of I. To find the coordinates of any point or any midpoint in a system of axes, we should find its abscissa. So the abscissa of I is equal, because it's the midpoint of EM, it is the abscissa of E plus the abscissa of M. We divide them all by 2. The abscissa of E is -2 plus the abscissa of M is 4/2. So it will be 2/2 equals to 1. Now also to find the ordinate of I, it's equal to the ordinate of E plus the ordinate of M, all divided by 2. The ordinate of E is 3 plus the ordinate of M is 3, all divided by 2, so 6/2 is equal to 3. So I, which is the midpoint of EM, has an abscissa 1 and ordinate 3. Let's now see where is I. It has an abscissa 1 and an ordinate 3. So this will be I, the midpoint of segment EM. Question number 3, we should calculate addition, subtraction, multiplication, and division of signed numbers. First, we have -5 plus -2. Addition of two signed numbers having the same sign, so the sign will be negative, and we add 5 plus 2 is 7, so it's -7. 7 plus -9, because we have addition. We look, the first sign is plus, the second sign is minus, so different signs. What's the sign of the greatest number? It's negative, so the answer will be negative, and we subtract 9 minus 7 minus 2. Now we have -2 plus 6, always also addition of signed numbers having different signs. The greatest is positive, so it is plus, and we subtract 6 minus 2 is 4. Addition of two signed numbers having same signs, positive, the sign will be positive, and we add 4 plus 6 is 10. Now we have subtraction of signed numbers. The rule of subtraction is we keep the first number as it is, we change minus into plus, and we find the opposite of the second number. The opposite of +5 is -5. Now we have addition of signed numbers having different same sign, negative, so the answer will be negative, and we add 3 plus 5 is 8. Here we have a numerical expression. We have here plus and we have here minus, so we should start from left. We have addition of two negative numbers, so the sign will be negative, and we add 4 plus 3 is 7 minus -7. Now we have subtraction, so we apply the steps of subtraction. The first number as it is, we change minus into plus, and we find the opposite of the second number. We are adding two opposite numbers, so always the result will be 0. Now multiplication of signed numbers. Negative times positive is negative, 3 times 7 is 21. Positive times positive is positive, 9 times 2 is 18. Negative times negative is positive, 5 times 5 is 25. Negative times negative is positive, 8 times 1 is 8. Now we have a numerical expression. Negative times positive is negative, times negative is positive, times negative is negative, times negative is positive. Now 4 times 5 is 20, 20 times 1 is 20, 20 times 3 is 60, 60 times 1 is 60, so it is positive 60. Now division. Negative over negative is positive, 48 over 6, so the result is 8. Negative over positive is negative, 12 over 4 is 3. Positive over negative is negative, 35 over 7, it is 5. Now a numerical expression. Because we have division, multiplication, multiplication, division, multiplication, we start from left. 32 divided by 8 is equal to 4 times minus 5 times minus 1 divided by 2 times minus 9. Also we start from left. 4 times minus 5 is minus 20 times minus 1 divided by 2 times minus 9. Now also from left, negative times negative is positive, 20 times 1 is 20 divided 2 times minus 9. Now positive divided by positive is positive, 20 divided by 2 is 10 times minus 9 is equal to minus 90. Now we should make calculation of powers. 5 squared, we write it as a multiplication sentence. 5 times 5 is equal to 25. 10 cubed, this is a power of 10. So we take 1 from the base and we add zeros as the power. 1, 2, 3 zeros. 8 to the power 0, this is a rule. Any number to the power 0 will give us 1. 1 to the power 45, also this is a rule. 1 to the power n or any power will always be 1. Now 10 to the power 6, also this is a power of 10. We take the base, from the base we take 1 and we add 6 zeros as the power. 1, 2, 3, 4, 5, 6. Now 3 to the power 4, we make a multiplication sentence. 3 times 3 times 3. It is equal to 3 times 3 is 9, 3 times 3 is 9, 9 times 9 is equal to 81. 344 to the power 1, any number to the power 1 will give us the number itself. Now 4 times 4 squared, any number which its exponent is not written, it will be 1. Now this is a rule. We have same bases, so the base will stay as it is and we add 1 plus 2 is equal to 3. Now what's 4 cube? It's 4 times 4 times 4, which is equal to 64. Now we have also same bases, so the base will be 9 and we add 0 plus 2, it is 2. What's 9 squared? It's 9 times 9, which is equal to 81. Also now we have base 7.3, base 7.3, so it will be 7.3 and we add the exponents. 3 plus 5 is equal to 8. Here this number, there is no need to make its calculation. 2 times 4 squared, we can perform it. If we multiply 2 times 4, it will be 8 squared, so we write 8 times 8 is equal to 64. 11 to the power 0, all of it to the power 11. Here we multiply the exponents, so we will get 11 to the power 0. Any number to the power 0, it will be 1. 5 times 4 cubed, we multiply 5 times 4, it is 20 cubed, so we write 20 times 20 times 20. 2 times 2, 4 times 2 is equal to 8 and we add 3 zeros. 30 to the power 4, also we write 30 times 30 times 30 times 30. 3 times 3, 9 times 3, 27 times 3, it's 81, and we have 1, 2, 3, 4 zeros, so we add 4 zeros beside it. 10 over 3, all of it cubed. This is a rule. It's written 10 cubed over 3 cubed. What's 10 cubed? It's 1 and 3 zeros. What's 3 cubed? It's 3 times 3 times 3, which is equal to 27. We can't reduce this fraction. 1 over 2 squared times 1 over 2 cubed. Here we have same base. So the base might be a whole number or a decimal number or even a fraction. So the base here is 1 over 2. and we add the powers. 2 plus 3 is 5. So this is written 1 to the power 5 over 2 to the power 5. So this is 1 over 2 to the power 5. The answer is 2 times 2 times 2 times 2 times 2 is equal to 32. Now here we don't have a rule. We calculate each power alone. 4 squared is 4 times 4, which is equal to 16, plus 3 cubed, it's 3 times 3 times 3 equals to 27. Now we add 6 plus 7, it's equal to 13. 3, 1 in hand. 2 plus 1 is 3, and 1, it's 4. 2 squared times 10 to the power 0. Here we have parentheses is the strongest, but if we look inside the parentheses, we have exponent and multiplication. Exponent, we start with the exponent first. So we write 2 squared is 4 times 10, all of it to the power 0. What's 4 times 10? It's 40 to the power 0. Any number to the power 0 will give me 1. Here we have a numerical expression. We should apply the order of operation. We start first with the parentheses. So we write 4 squared plus 10 minus 3 squared, all of it squared, plus 5 squared minus. What's 5 times 2? It is 10 to the power 0. Now we have rules of powers. We start from left. 4 squared is 4 times 4, which is 16, plus 10 minus 3 squared, all of it squared, plus 5 squared minus 10 to the power 0. Also we start with this power, so we write 16 plus 10 minus. Here we have multiplication of powers. 2 times 2 is 4, so 3 to the power 4 plus 5 squared minus 10 to the power 0. Now we start with this power. So we write 16 plus 10 minus. What's 3 to the power 4? 3 to the power 4 is 81 plus 5 squared minus 10 to the power 0. Now we start with the 5 squared. 16 plus 10 minus 81 plus. What's 5 squared? It's 25 minus 10 to the power 0. Now with the last power, 16 plus 10 minus 81 plus 25 minus, what's 10 to the power 0? It's 1. I will continue up here to finish. Now we start with 16 plus 10. 16 plus 10, it's 26 minus 81 plus 25 minus 1. Now we have 26 minus 81. The negative is the bigger, so we have minus 6 minus 1. We have 1 minus 6, we can't, so 11 minus 6 is 5, and here we have 7 minus 2, so it's 55 plus 25 minus 1. Also we start with the addition from left. We have the negative is the greatest, and we subtract. 5 minus 5 is 0, and 5 minus 2 is 3, and minus 1. Here we have two negatives, so it's negative, and we add, so it's minus 31. Question number 4. Read well, then answer by true or false. The scientific notation of 5108000 equal 51.08 times 10 to the power 5. We all know that the scientific notation, we should have the number between 1 and 10, but 51.01 is not between 1 and 10, so this is false. The product of two negative numbers is negative. If we have a negative number multiplied by a negative number, it will be positive, not negative, so this is false. Minus 2 is less than minus 5. There is a rule that say as we go nearer to the 0, the negative number becomes bigger, so this is false. 2 plus 7, all of it cubed, is equal to 2 cubed plus 7 cubed. No, this rule applies if we have multiplication, but in division, in addition, no, we should add these, all of it cubed. So this is equal to 9 cubed, which is false. The sum of two opposite numbers is 0. If we are adding two opposite numbers, a positive number added to a negative number which are opposite, yes, the answer will always be 0. 9 is a prime number. This is false, so this is true, sorry. 9 is not a prime number because 9 has divisors 1, 3, and 9. If we divide 9 by 1, it will give us 9. If we divide 9 by 3, it will give us 3. If we divide 9 by 9, it will give us 1. So this is false because 9 is a composite number and not a prime number. In question number 5, we should write the following numbers as product of prime factors. 48. To make the prime factorization of numbers, we should try to divide the number 48 starting from 2. Can we divide 48 by 2? Yes, because the ones is even, so we can divide it by 2. 48 divided by 2, the answer is 24. Also, we can divide the 24 by 2 because the ones is even. 24 divided by 2 is 12. Also 12 is divided by 2 because the ones is even. 12 divided by 2, the answer is 6. Also because the ones is even, 6 divided by 2, the answer is a 3. Now 3 cannot be divided by 2. 3 we can divide it by 3, the answer is 1. When the answer of division is 1, the prime factorization of 48 is finished. So these are the prime factors of 48. Here in this side, we should not have composite numbers, we should have only prime numbers. So the prime factors of 48, if we want to write them as a product of prime factors, we have 1, 2, 3, 4. 2 is 4 times, so we write it 2 to the power 4 times 3. These are the prime factors of 48. Now 144. Also, we can divide 144 by 2 because the ones is even. It will give us 72. 72, it can also be divided by 2. The answer is 36. 36 can be divided by 2. The answer is 18. 18 can be divided by 2. The answer is 9. 9 can be divided by 3. The answer is 3. And 3 is divided by 1. We finished the prime factors of 144, and these are the prime factors. So 144 as prime factors equal 1, 2, 3, 4. So 2 to the power 4 times 3 squared. These are the prime factors of 144. Now the prime factors of 300. Also we can divide 300 by 2 because the ones is even. It will give us 150. 150 can be divided by 2 because the ones is even. It is 75. We can divide 75 by 3 because the sum of digits is a multiple of 3. It's divided by 3, it will give us 25. 25 can only be divided by 5. It will give us 5, and 5 is only divided by 5. It will give us 1. We stop. These are the prime factors of 300. So 300 equals, we have 2 2 times, so 2 squared, 3 1 time, and we have 5 2 times, so we write 5 squared. These are the prime factors of 300. Now the prime factors of 160. Also 160 can be divided by 2. It gives us 80. 80 can be divided by 2. It gives us 40. 40 can be divided by 2. It gives us 20. 20 can be divided by 2. It gives us 10. 10 can be divided by 2. It gives us 5. And 5 is only divided by 1. So we have finished. These are the prime factors of 160. The prime factors of 160 are, let's count how many 2's do we have. 1, 2, 3, 4, 5. So 2 to the power 5 times, because we have 5 one time, so we write 5. These are the prime factors of 160. I really thank you, my dear students. Please revise well and study well for our semester exams. Nothing is impossible, and I love you very much. Thank you.